What's up, guys? Welcome to today's show. So last time we started a new project, creating our own curses library for console graphics. And what we did last time was we defined a window data structure, and this is for full screen windows. And each window contains a frame buffer, which is a linear frame buffer that when we want to change something on the screen, we update one of the frames, and then we run an update function which will turn that into stuff on the screen. And why we do it with a frame buffer like that is so we don't have to update the entire screen every time, because that would cause flickering and whatnot, plus it wouldn't be very effective. This way we will just set a boolean. So we'll change one bit when we update a frame, and then we can just go through the ones and take the value from here and put it on the screen. So that's the general idea, and the only functions we did last time was some constructor function which creates basically empty versions of these data structures. So today I want to create something more concrete. So I would like to create the update function today. We'll see if I will be able to do that, but at least I want to start by creating some functions for modifying the frame buffer. So if we want to, for instance, have a putchar, let's say we have that. So it will be something like void putchar, and I'm going to prefix all with a C for curses, which is the name of this library, at least when it comes to the public API, which this is a part of. So let's say this is a public function. And public, by the way, is defined as this. So we set the visibility attribute to default, which means that it will be exported when we create the library. Okay, so what arguments should a putchar take? The regular putchar only takes one argument, which is the character we want to print, so we'll do that. But we also need to specify which window we want to print it in. And we don't need to specify where on the screen we want to put it, because we'll have a separate function called, I don't know, move or jump or something, which will move the cursor beforehand. So we don't need to do that. However, we do need to specify the coloring, and that will be two values, one for background and one for foreground color. Okay, so if we want to have a public function like this, what do we need in terms of private functions, like utility functions, to make this happen? Well, first of all, we need to be able to modify the frame buffer, right? So let's say we have something like, let's say we have a private function which, let's see, say we have set frame buffer or something, and we're going to do it in two different ways. Maybe we can say this is set frame buffer like this, and we need to do it in one of two ways. We can do it linearly, or we can do it XY. So basically we can treat all the frame buffer, all the frames on the screen, as one long single-dimensional array. Or we can treat it as a two-dimensional array with XY coordinates. And sometimes one is good and sometimes the other is good, so we need a function for each. So let's say this is the linear one. We need to specify the window, we need to specify the character we want to put there. We need to specify foreground color and background color. Let's see. And in this function we do need, let's see, do we need to specify where we want to put it? I think so. So let's say the last argument is the index of the frame buffer, where we want to put it. And then we will have an almost identical function which is called setFrameBuffer XY. And instead of having an int16 here, we're going to have two int8s, one for the x coordinates and one for the y coordinates. If we manage to create those functions, it will be rather easy to create this one, right? Because this will just call one of these. I guess the xy, right? Or maybe the linear one. We'll see. So these three, sorry. So these three we need to create, and I don't think it'll be very complicated. Let's start with the linear one. That way we can use the linear one when we call this XY one. So let's go to the top actually. By the way, we need to have some return value here as well. I guess it's void. Same here. Alright, so let's see. We need to have a window. We need to have a character, C. We need to have colors, so foreground color, background color, and int16 index, like so. Okay, so how do we do this? First we need to check some stuff. We need to check that let's see, if we don't have a window, or if we don't have, I guess this is the only thing, then we'll just return since it's a void function. Alright, so let's see. Well, first we need to create the coloring value, because as we can see, a frame buffer is consisting of several frames, and a frame is a int16. And why int16? Because we have an int8 for foreground color and an int8 for background color. So binary it's going to look something like this. We have foreground color 1, 2, 3, 4, 1, 2, 3, 4, and we have background color 1, 2, 3, 4, 1, 2, 3, 4. So the least significant bits are the foreground color. So we need to do some binary bitwise operations. Let's say we have an int16 color where color is equal to well, we take the background color and we shift it 8 bits. So it ends up here. And then we'll just add the foreground color to it. So we can do an OR operation with the foreground color, and we're done. So that's a coloring info. We don't need to do any calculation regarding the index because, well, this is the index. We don't have any XY to calculate. And the character is just a character, so... by the way, I did this wrong, actually. The coloring information is just 8 bits, not 16. So actually it looks like this. Foreground, foreground, background, background, and then we have the character here, like so. So we need to redo this actually. Let's say the coloring info is 8 bits, and then we have the frame, FR, which means we need to shift it not 8 bits but 4 bits, and then we have the color, and the frame we get by taking the character, shifting it 8, and OR it with the color. Okay, so now we just need to update the frame buffer. Maybe we should double check that we actually have a frame buffer. By the way, we need to update the bitmap as well. So let's see how we did this. Okay, this is a pointer, and this is a pointer, and this is just an array, okay? So let's check that we have a window. Let's check that that window has a frame buffer. Actually, to call it FB, right? Yes. And that it has frames. Okay, so now we have done all the sanitizing we need. Now we just need to update the thing. So the window frame buffer frames at index should be equal to the frame. And then we need to set, what did we call this macro? Set bit. And we have the bitmap and the bit. So we're going to set the bit of the window frame buffer bitmap for BM bitmap. And the bit we want to set is the index. and then just we return. Simple enough, no? Okay, so let's copy this thing, paste it in here, and this is going to be the set framebuffer xy, which means we're gonna remove this index and instead have an int 8x and int 8y. Which means the only thing we really need to calculate here is the index. And that is a 16-bit value, index. So basically the index is going to be, well, before we can calculate the index, we need to check at least that we have a window, right? Otherwise this might crash. So let's see. We also need to check if we need to have some max x and max y values. And the max x is going to be the Windows let's see which one is which. So the x is like this axis, and that would be the cols, right? So the window cols, and this is one index, so we need to take it -1. And that's the max x. Similarly, the max y is the window rows -1. And what are we going to do if we put too high value here? By the way, we need to do some kind of check here as well then, that the index is not out of bounds. So let's have something like max index. Where max index is going to be the window cols -1 times the window rows -1. So this is the maximum index. And if index is more than max index, should we just return, or should we raise an exception? Or should we simply set the index to max index? I'm not really sure what I want to do here, so let's for now just return, and we'll do similar thing here. So the index is going to be, first we do the check. So if max x, no, if x is more than max x, or y is more than max y, we'll just return. Otherwise we set the index equal to didn't do this the right way. So the max, oh wait, that did actually. But when we calculate the index though, we still want to take the y parameter and we want to times that with the max x. And then we want to add the x. Because this takes us a number of lines down, right? And this takes us a number of columns to the right. So this is correct, I think. All right. And when we have the index, we can simply use the other function, which was called sfblinear. And what do we have? We have all the same but the last. So we'll give the window the C, foreground color, background color, and then the index. And we'll return the result. Simple enough. So that way we can update the frame buffer. Let's see if this compiles. sfbxy. Why did I call it? sfbxy. sfblinear. sfbxy. Am I blind? sfbxy. sfbxy. Defined but not used. Okay. Well, we haven't gotten around to it yet, right? So I guess this compiles fine. But we can't really do anything with it right now. First we need to we need to be able to move around. So maybe we should create that function. And ncurses calls it move. I think I want to call it jump, just to be a little bit different. So let's say we have a public void C jump, and it takes a window, it takes an X, and it takes a Y. So let's see, public void C jump, we have a window, win, we have an int 8 x, an int 8 y. y. We need to check that we have a window. And we need to do the same check as before. So let's define max x and max y. And if max x is equal to the window cols minus 1, max y is equal to window rows minus 1. And if x is more than max x, or y is more than max y, we return for now. Otherwise, we're just going to change the current value, because inside of this structure we have an x and a y, and that's a current cursor position. So we will just set window x is equal to x, window y is equal to y, and we return. It doesn't have to get much more complicated than that. Okay, so are we ready to create this cputchar thing? Yes, we are, right? And we have a window, we have a character, we have xy. Oh, do we now? No, these are colors. That's right. Because it's going to read the xy from this, right? And probably gonna advance the cursor as well. Okay, so let's create this thing. Public void cputchar. Gonna have a window win. We're gonna have an int8 character, int8 foreground, int8 background. So let's see. Let's do a similar thing here with max x and max y. And if we don't have a window, we return. So the current position of x and y is already sanitized, which means we don't have to worry too much about that. But the new position we need to calculate properly. So the x is going to be the window x and the y is going to be the window y. And if x is less than Alright guys, where were we? we were calculating the max x and y, right? This is rows minus 1. And let's see here. What we are interested in is x less than max x. Because if it is, all we need to do is increase x. So we move the cursor one position to the right. Otherwise, well, at this point x cannot be bigger than max x, but it can be equal. So we can do else if. This means that x is equal, and we want to check if y is equal to max y. So this means that the cursor currently is in the bottom right corner. And what we can do at this point is debatable, but let's say we set x and y both to 0. And otherwise we're in a position where x is equal to max x, so it's on the rightmost part of the screen, but y is not equal to max. And in that case we want to set x to 0, and we want to increase y. So we move it down one position to the left. Alright, so now we have the old position, or the current position, and we have the new position. So I guess we can just print the character. And since we have an x and a y, we can just return our, what's it called? sfbxy, right? So set framebuffer xy, and we have the window. What else do we need? Character, foreground, background. Character, foreground, background, and x and y. And that's, ladies and gentlemen, is how we print a character to the screen by modifying our frame buffer. We still, however, need to create the update function, which will actually take the frame buffer and put it onto the screen. So I guess that's our next logical step. We are going to have a public void c update, which just takes a window as an argument and print it to the screen. So now we get into how do we print stuff on the screen. Well, we have the system calls read and write, which we are going to use, but it's not enough, since they only put something at the current cursor position, which we cannot really change with a standard API, because that's why we're building our own, right? But there are something called ANSI characters. So if we search for ANSI codes. There is something. Is it this perhaps? Yes, this is a very good page. I will link to it in the description. Maybe I can save this right now so I don't forget. So let's see. Okay, so ANSI codes, we can use them to move around on the screen to generate color, and they will be interpreted by our terminal. So for instance, here are a couple of cursor controls. Move cursor to home position, move cursor up and down and right and left. So we can use all of these, and the escape character is, I don't remember, it's one of the early, maybe it's even 1 or 0, something in the lower range of ASCII. We need to figure that out. And this is interesting because here we can use stuff like bold mode, which basically just means it's a little bit lighter. But here we have the color codes. And if I remember correctly, they are 16 different codes. Maybe not quite. And anyhow, there are a couple of colors we can use. So this is basically how it looks. 1B, that's apparently the ASCII color code for the, the ASCII code for the escape character. So escape B, and then we have this bracket, and we have a 1, and then we have the color code. And then we have some text, and then after that we have some reset character, I think. Where is it? This one. So we will end with this one. And then we'll have our character in between. So that is how we're going to print to the screen. And we're going to move around on the screen using these ones. But before we can use any of this, we need to be able to set the current, well, we can actually use some of them here, but what we need to do is being able to read from the screen. And we need to be able to read without any buffers. We want to have, if the user presses a key, for instance, we want to get that key instantly. So how do we do that? I have actually done something similar, or exactly the same, in my runlock project. And I don't know it by heart, so I'm gonna cheat a little bit by looking at my runlock code. Let's see, I think it's in this util. If we search for, I think I called get password. Okay, so this get password function reads a password from the screen without echoing it. And that's basically what we want to do. So I used a macro that I created, which is called echo off. And that is what we need to be using. Let's see if I have this in this file. No, I think I have it in this H file. So echo guess this is the one. So what we're going to use is something called tcgets, and that's an argument to the IOCTL system call. And we need to modify some flags. So here we define those get and set. These are the constants we're going to use. And then we have something called term.io, or termios maybe, where we're going to change the C flag, CL flag, and this vtime and vmin. So there is also a man page. If we go to IOCTL, I think this is in page 2, and so I think terminal maybe, or termios. What is it? IOCTL. Let's go to IOCTL and see what we link here. IOCTL TTY, that must be it. Okay, so we give a file descriptor, so that's the standard input, for instance. We give a command and we give the arguments. And here we have the tcgets and tcsets, which changes this termios structure, which is struct termios. And let's see if we find this terminal structure somewhere here. Win size. Okay, so here we have struct terminals. So these functions are basically library functions. So if you don't run Linux, for instance, you probably want to use these instead. tcget attribute and tcset attribute. But I like using the lower level stuff. And here we can see we have these flags, and we are interested in this one, local modes. And also this one, which contains the, what did we call it, xmin or something. Vmin and vtime. And if I remember correctly, we are going to set both of these to 0. What do we do here? We move the address of this to ECX and EDX. And we move into EBX the contents of EX, that's the L flag. Well, I think that's it. So basically we need to create one of these terminal structures. We need to read in the L flag using tcgets. Then we need to modify, so we remove this echo flag. We set those to 0, and then we execute the tcset attribute, which we do here. by calling ioctl as well. Alright, let's see if we can turn this into some C code. First of all, let's find this terminal string. We need to include this terminals.h, I suppose. Or maybe we can get away with just these. Let's start there. Alright guys, so let's start by taking these include files and let's add them here. And let's see. I think we are going to save a copy of this structure inside of our state, because then we can restore it afterwards. So let's say we have a struct terminals term or something. So we keep a copy of it right here. We need two functions, one to restore the terminal and one to prepare the terminal. So let's create those. Let's say we have a private void, what should we call it? Let's say termenable and termdisable. And the only thing we're going to give this is a state pointer. And we're going to have a private void termdisable, which also is going to take the state pointer like so. So let's start with the enable function. So we have a private void term enable. We have a state st. Alright, so first of all we need one of these structures. So struct terminals term. And then we need to call, we probably need a signed integer for the return values. So then we're going to call ioctl with some args, and it will generate a return value. So let's see if we can figure out how to use this thing. Okay, so we want to get this stuff, and the argument is a pointer to the struct terminals. Alright, that's easy enough. So here we need a file descriptor. I'm not sure which one yet, but we're gonna use this and the address of this term thing. But are we gonna use standard in or out here? I suppose it is standard in, but I'm not 100%. Let's check this assembly code. So this is our secho function, and when we call let's see, here we do the gets, and we call ioctl, and we push ex, which is XORed with itself, so that means it's 0. So we have a 0, and we have the TC gets. And we have an argument, which is a struct termios. But I'm not really sure about the order here, because the 0 is pushed last, so that should be the first. But then we have the TC gets, and then this. That doesn't seem right. Actually, this does make sense. So the 0, and then the command, and then the argument. Alright, so this x right here should be a 0. And let's see what the return value of IOCTL is. If we can find it inside of the manual. 0 on success, alright. So if rect is not 0, then we'll simply return. Otherwise, we will have the data inside of this term thing. So let's see how we are going to change that. So we're going to alter this CL flag. And we're going to set these to 0. By the way, before we do anything else, let's copy this structure to our state. So we will have a copy function. We haven't written that just yet, but we are going to copy into our state term, and we're going to copy from this structure and size of struct termios. And let's for now say that maybe we shouldn't cast these, because we are going to use different data types in our own function. But for now, just to make things simple, we will just say that copy of destination source size is the same as memcopy and we will cast to a char the destination. We will cast to char our source and then provide our size. Something like that. We will write our own copy function later on. Okay, so now we have this one saved. Maybe we should try to look up how this terminal structure is defined. So it should be in these ASM term bits. Oh, I never seem to remember what directory the files are in. So let's see. The architecture is it's i686. i386. So, okay, if we go into this directory and then into ASM, do we have this term bits? ASM generic term bits. Okay, here we go, struct terminals. So here we have the different flags, and all of these are unsigned integers. And then we have this. So this CCC we want to set to 0, but it would be good to know exactly which one is which, because this is 19 characters. I wonder if the manual says something about that. So doesn't talk much about that. Perhaps in the terminals thing, special characters. The symbolic indices and meaning are. Okay, so here we have the different things. If we look at this, we're interested in vtime and vmin. Do we have those? Vmin. And vtime. Okay. So probably we should be able to do something like this. If we go to our term and our CCC at index vmin, we should be able to set it to 0. And we should be able to do the same with, what was the other one? vtime. Okay, so that's one thing. The other thing is we need to change the echo flag. So how do we do that? So move ex echo, so it's inside of this. And if we want to enable it, we OR ex with ebx, and what's inside of ebx? the CL flag. Okay, so we take the L flag and we just or it. So we need to know which bit is the echo. Let's look at this. Where is it? Here. Does it say anything about echo? All right. So we have echo. What? It was one more thing. Yes, this I canon. Do we have that too? I can. Yeah, here it is. Okay. So we take the term CL flag and we want to or equals echo, and same with the, what did we call it, I canon. And now we just set these attributes. So we do rect is equal to IOCTL. This is still 0. This is TC set S. And we give it a structure. And if we have a positive rect, we just return. And otherwise we also return, so we don't really need to do this here. What happened to my keyboard? Weird. Okay, so this is the termenable. The termdisable is going to be similar, but not quite. So this is the termdisable. Here we don't need this. And we don't need to do a gets. We can go directly to the sets and we give the state term instead. And we don't even need to check for the return value actually, because no matter the return value, we are going to just return, right? So, yeah, I think this is it. Maybe we should have some kind of check that we at least have a state. And if we don't, we can just return. And we need to do the same up here. And if we don't have a state, we just return. Okay, I think this is it. So let's go to our initialization function. And after we have created the window, or rather before that actually, we will do term enable and we give it the global state. Like so. So how can we test this? I guess we can test it by trying to read from standard in, because it should only read one character enter at the time, and we shouldn't be needed to press enter or anything. So let's say we have some temporary buffer. Let's make it easy and make this a char emp 2 bytes. And we read from standard, let's see, standard in, out, error. We'll read from standard in, and we give it the, well, address of TMP, I guess. And 1. And let's just print what we got. Maybe we should clear this out first. So TMP is equal to TMP plus 1 is equal to 0. And then we print 0x percent to hhx, new line, and we give first character of TMP and return 0. Alright, let's try this out. Close the wrong window. So let's see, it's better. TMP ncurses. This should be our home. Make clean, jump down a little bit, clear the screen, and boom. Ret undeclared 31. Well, let's do this. Term disabled, defined but not used, that's okay. Alright, let's see what we got here. Not really. What happens when we run that thing? IOCTL gets, and we get a lot of stuff here. And then we do the sets. And let's check the L flag. So we have the iCannon set here and the echo. And here we still have the iCannon and the echo. CL flag. Oh, wait a minute. We want to remove those, right? Not create them. Because we are adding those flags, but we want them gone. So basically what we do need, we want to and equal this instead. And we're going to take the echo ANDed with iCannon, and then we take the inverse. Like so. Okay, the echo is gone, but it didn't really let us read anything. Well, at least the echo is gone, but why wouldn't we be able to read? Let me just check this code again. So we do all of this, and when we want to run, let's go into this one, and let's check the get password. So it runs echo off. And then how does it read? Move this, pop, state, buffer, ex, push ex, XOR, byte, call read one. So where is read one? Here. Three. So 3 is probably the read number for the system call. And we read from standard in. And ECX is the buffer. And we read 1 byte. So this is basically the same code as I wrote here inside our main. Let's see what happens if we do this twice. Well, will we get this 0 thing every time? And maybe we should do this. I don't know if it makes a difference. It probably breaks down to a pointer anyway, right? Maybe we shouldn't set it to 0. What do we do inside of here with regards to the vmin and stuff? So s echo. So vtime is in ECX, vmin is in EDX. So let's see. All right, now I figured it out. We should set this vmin to 1, so it reads 1 character. So now when we run this, we can grab each character. But we still need to reset the display manually by the end. So we need to make sure that when this unloads, we run the termdisable. So I guess we can do it the same way as we did with the init function. And let me see if I find my definition. Right here. So we create a similar one. Let's call this fini. And instead of constructor, so we need a destructor. So let's search for init. Here we have it. So let's say public. And this is going to be the fini function. So initlibrary and I don't know, exitlibrary. And all we're going to do here is first we check that we have a global state, and if we do, we call termdisable with this global state, and then we return. I think this is going to work. So where is init here? So initlibrary. This should be public init void, and this is public fini. And we call this exitlibrary, like so. All right, let's try this again. Oh, I forgot a little something. This should be void, right? All right, so now we do this and A, B, and now it has reset the screen. All right, nice. Now we can finally code our update function and actually put stuff onto the screen. Right. By the way, I want to fix one bug first. Or not a bug, but I want to do one optimization. When we write to the screen using, I don't remember what we called them. Here, sfbblinear and sfbxy. Let's see. I think we only need to change the linear one, because here we change the thing that we want to change in framebuffer, and we set the bit in the bitmap. That's all fine and well, but what if we want to print some character in the same color as the character which is already there? In that case, we don't want to mark it as a change, because then we would need to update it in vain. So let's do a check. If the window framebuffer frames at index is not equal to the new frame, in that case, and in only that case, we are going to do this stuff. Otherwise, we don't change anything. Okay, that's good. What else? Yes, I want to do one more optimization, because we are gonna go through this whole bitmap bit by bit every time we update, and I want to make this a little bit more optimized. It's going to be a linear search either way, but we can start at different positions, right? So let's say that we have a bitmap that looks like this from the beginning, all zeros everywhere, and then at one point we change something and this will be a 1. When we do the update function, we don't want to go through all of these leading zeros, we want to start at the first bit, which is set, and then go from there. I think that is a better solution. So we can save the index of the first one. So inside of this frame buffer, we are going to add one thing, and this is going to be, it's going to be an int16, and this is the, what should we call this? The first 1 bit. Yeah, let's call it F1B, first 1 bit. So let's see, we need to change the constructor. So that's the make frame buffer. And we want to explicitly say that FB first 1 bit is 0. So this is the index. So 0 means that we start from index 0 when we go through this thing. So when we do the set bit, or actually when we do the function we just did stuff inside, the sfblinear, when we change this here, we want to change this as well. So let's see. So the IDX contains the index of the bit which we will turn into a 1. So if that index is more than the window frame buffer first 1 bit, and since this started at 0, first time we set this, it will be more, and the next time it might be more if we set an earlier bit. Let me see, am I thinking this correctly? So if the index is 5, for instance, then it's more than 0, and we want to set this. But if it's 3, yeah, we can't do it like this. We need to check if this is 0, then we want to set it. Or if this window frame buffer first 1 bit, if this is more than the index, so the index, yeah, in those cases we want to update this bit. So then we set the first 1 bit to the index, and then we set the bit. And I guess that's all we need for this thing. And we have to remember to reset this first 1 bit when we reset the actual buffer. Okay. So I think it's time for the update function, but we do need to deal with the ANSI codes in some good way as well. So I think I'm going to create a specific file for that. Let's say we have an ANSI.c. the ANSI codes, that's these ones, right? That we use to control where we move on the screen and what colors we use and so on and so forth. So basically, this file should contain different functions which return a string, basically. So we give it like a number and it returns an ANSI string using that number. So let's create one for the move to begin with. We need to include well, we need to include the curses.h, I suppose. So let's start with this. It's not going to be private because then we can't access them, but we don't want it public either. So these are going to be protected, which means that we can access them in different translation units, but not from outside. So we're going to have a protected, well, an int8 is what it's going to return. And let's say this is the ANSI move. So it's going to take 2 int8s for the position. And what is the ASCII, the ANSI code for moving around? Here. To line number and column number. Alright, so protected int8 ANSI move. We're going to have an int8x and int8y. And I think I'm going to use a static buffer. So a static int8. And how many characters is this? So this is 1, this is 2, and then the line is up to 3 characters. So that's 5 and 6, 9 and 10. So let's make this 16. Let's start by zeroing it out. Since it's a static buffer, it's going to retain the value. So 1 of 16. Right. So basically we're going to do an smprintf, I guess. So we're going to go into the buff and maximum size 15. And we're going to do the X, was it 1B? Let's double check this escape character. I had an example somewhere. Yes, X1B. So X1B, and then we have this. And we have the line number, semicolon, and the column, and then an H at the end. And the line that is the Y value, right? we give y, and maybe we need to do this. We give y and we give x. Maybe we need to do this actually. Alright. And we need to figure out the length of this thing. So let's have an int 8n. We set n equal to string length, which we need to string len, which we need to define. So we give the buff, and then we write to standard out buff with the length n. No, we don't do that actually. Or maybe we should actually do that. I thought first that I want to return this thing, but actually we don't need that in this case. So let's make this a void instead. And then we write this, and then we just return. So we don't need to have it as a static buffer if we're not going to return anything. The other functions is like with color codes and whatnot. There we probably need to return it. I think that's the best way to deal with it. String length needs to be defined, and we'll do like we did with the other ones. We do them temporarily using the standard C library, but later on we're gonna create our own. So string length, and it takes an x, and we just call strlen, and we give it the character version of x. We also need to update our make file. So we have an ANSI O from an ANSI C. Run cc with the flags, -c this. And when we compile, we also give ANSI.o. And we're going to change the make file quite a lot when we turn it into a proper library, but for now this is okay. Let's see if it compiles. Line 4. Protected. maybe we should do this actually. These are just warnings, but I think we need to divide this, these header files a little bit better. But it seems to work. Pointer targets in passing signness. Okay, that I would need to fix. So this buff needs to be treated as a char. Otherwise, I think it's okay. Yeah, it's only these private functions. Alright, so now we have everything that we need in order to create the update function, which we are going to do after the break. So see you in just a bit. Alright, you guys, let's code an update function, shall we? And then we'll be able to put stuff on the screen. Pretty nice. So let's see how to do this. It's going to be, we have already defined the signature here. Alright, looks good. So let's see here. We're gonna have a public void C update. It's going to take a window win, and that's all. If we don't have a win, we are going to return. And I also want to do another check. If the window is not the active one, because if we're going to update a window which is not shown, nothing will happen. So we need to make sure that we are the active one. Okay, so the first thing we need to do is we need to go through this bitmap to see if there actually is something we need to update. So how do we do that? We will start at this index. So we're going to need a bool for the bit we are looking at. We also need to have an index. And do we have a maximum? How do we know a maximum? We need to calculate that from the columns and the rows, right? So let's say we have an int16 max. Let's start at that end. So the max is going to be well, we're going to take the window calls minus 1 times the window rows minus 1, and then we get the maximum index. So then we can just do a for loop where index is equal to the window framebuffer. What did we call it? F1b, first 1 bit. So that's where we start. We're gonna loop as long as idx is less than or equal to the max. And at each iteration we are going to increase the index. And what are we going to do inside of this loop? Well, we want to grab that bit to start with. So the bit is going to be the get bit of the window framebuffer bitmap. And the bit index is idx. Right. Yeah, I think this is correct. Let's check this get bit thing. So we have the bitmap and the bit. Okay. And if this bit is 0, then we just continue. Otherwise, we want to update the frame that corresponds to this index. So we need a frame. And the frame is going to be the window framebuffer frames at this index. And now we need to divide this thing into its different parts. So we're going to have an int16 color, but also an int8 foreground and background. And we're going to have an int8c for the character. So how do we get each of these? Well, by the way, we can optimize this get bit thing a little bit. We can check if the byte is 0. Because if the entire byte is 0, the bit, no bits can be anything but. So then we just need to check once and not 8 times for that specific byte. So we'll have an int8 byte where the byte is going to be the index divided by 8. And we're going to go to the window framebuffer bitmap at this index. So then we're at the correct byte. And if this byte is 0, we don't need to do any more checks, we can just continue. This is just a small optimization, or might be kind of big actually, because most will be 0. So alright, so now we have the frame and we want to grab, let's start with a character. So let's see, we have this. So the first or the high order byte is the character, and then we have background background, background, foreground, foreground. It makes it a little bit easier to have this in front of us when we do this calculation. So the character is going to be well, we take the frame and we AND it with 0xff00. So basically we mark this first thing. And then we need to push it 8 bits to the left. So then we have the color, the character. The color we'll do a similar thing with, but in this case we only need to do an AND operation. So we take the frame and we AND it with 0x00ff. And then we have the color at the right place. Alright, so when we have the color information, we can grab at the different colors. So the background color is going to be a similar operation, but we take the color and we AND it with 0x00 f0, and then we push it 4 bits to the right, and the foreground color is simpler. We only take the color and we AND it with 0x00f, and then we have the foreground color. And now we can just relay this to some utility function. Let's say, I don't know, updatewin perhaps. And we pass it the window and the character, the foreground color and the background color. That should be enough, right? And maybe we should compare if we are trying to change it to the same thing, but we have already done that check once, so I guess we don't need to do it again. It's only a optimization anyway, so let's not care about that. Yeah, I think this is good. And when we have gone through this loop, we have hopefully updated everything on the screen that we need. Now we need to clean out a few things. If we go to the frame buffer and the first 1 bit, this should be reset to 0. But we should also reset all the bits. So maybe it's easiest to just do set bit and provide the window frame buffer bitmap. Unset bit, and then we provide the index. So after we have updated that part of the screen, we reset this to 0. Is there anything else we need to change? Well, the actual frame we should also reset. So if we go to the window frame buffer frames at index, we can just set it to 0 like this. And then it's pretty much cleaned out. Do we need to change anything here? X, Y, calls, rows. No, not really. Alright, so now we just need to create this updatewin utility function. So window, character, foreground, background. What did I do now? Undo. So we're going to have a private void update window. It's going to take a window, it's going to take a character, it's going to take two colors, like so. So private void update window, and we have the window win int8c int8 foreground int8 background. And here we're going to need some kind of variable. Let's say this is the ANSI. If we don't have a window, we can return. So we need to have an ANSI utility function for this, but basically let's create two of these, ANSI and reset. And we're also going to need some buffer. So let's say buff, and I don't know how big this needs to be. 32 is a good number. So the ANSI is going to be something like ANSI color, and we just provide the foreground and background like this. And the reset is going to be ANSI reset without any arguments. And then we can put into our buff. Let's clear it out first, by the way. So we'll do 0 of buff, and the size is 32, and we need to cast this to an int8, and then we assign printf into this buff, 31 characters. By the way, we need to cast this into a char. So first we print the ANSI color code, then we print the character, and then we print the reset code. So ANSI C and reset, and this is going to be char, this is going to be char, and this will just be a char. Singular is like this. Let's also create an int8n where we set, or maybe we can have int16 so we don't have to convert between them. So n is going to be equal to our string len of buff. Alright, so after we have created this thing, we can just print it to the screen using the write. So what we're going to print is the buff, and we're going to put it into standard out, and we're going to have a size as well, and then we can just return. So all we need now are the functions for these ANSI stuff. So let's first create the signatures. Where do we put those? Here. So we're going to have a protected void, not void this time, int 8, ANSI color, and we need int 8, and it needs to be a pointer, and we're going to have a protected int 8 ANSI reset void. So we go into this ANSI file, protected void ANSI. Let's start with the easy one. Well, here we can just do this actually. We can just return a string, because this is going to be a static string, same every time. So we're going to have this x1b thing. Let's check what we are going to send more. Reset all modes. So this. We can just return it like this. Okay, so our next one is going to be a little more complicated, but not much. Protected, and not void, by the way. This is going to be an int 8 star. So protected int 8 ANSI color, int 8 foreground, int 8 background. And this is going to be pretty similar to what we have up here. So let's copy this here. But this time we do want this as a static buffer so we can return it. And we're not going to write anything here. So let's get rid of those two. And we are basically just going to return the address of buff. Okay, so how do we do this color code stuff? Okay, so these are the color codes. Let's see where we do the actual coloring. Set bold, set underline, set blah 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 blah. Graphics mode. Alright, now I think I have figured it out. So here is a good example. Let's copy both of these. And let's put them up here. Okay, so this first thing in this case makes it dimmed, but I think we can have a 0 there so we don't affect that kind of stuff. And then we just have the foreground and background. But we need to calculate the actual values because we don't have them from 0 to 15 like we have stored them in our case. But we have those from 30 to 39 when the foreground, and from 40 to 49 when it's background. So let's create int8 let's say fg color and bg color. Where the fg color is equal to the foreground color plus 30. And is it regular for 30 or hex? I think it's regular. Whereas the background color is just the background plus 40. So let's see. We have this escape character and this, and then we'll have a 0, I think. If it doesn't work, let's change it to 1. And then we have color 1, we have next color, and we end with a small m. So this is going to be the foreground color. And this is going to be the background color. Something like this, right? And that's pretty much it, I think. Besides some troubleshooting, perhaps. Yeah, not much actually. Only those annoying warnings that we had the last time too. But perhaps it's something else. Yeah. From a function with incompatible type, int8 unsigned char. Okay, we need to check this out. Sure, actually, why it doesn't accept this thing, but let's do something like this then. Int8 buff pointer, and before we return we set buff pointer equal to address of buff, and let's return the buff pointer. Okay, we got a lot of these weird warnings. That's all the warnings we get. That's good. Those we will fix later when we refactor our code a little bit. All right, so let's try this out. We already have some kind of main function, right, where we read from the keyboard, but we don't need to print anything with this. It's good that we read so we can see the results on the screen. Okay, so how do we do this? first we need to do a cmove, right? And let's grab the window. It will make things a little bit easier. So the win we take from the global state, win, I think. Let's see. Root, okay. So cmove, I guess it takes a window, and it takes, let's move to, I don't know, 10 lines down. Which order is this, by the way? Cmove. Haven't we defined the move yet? Ah, cjump. So window xy. So we do cjump window. So x, let's say 5 lines in, 10 lines down. And then we want to do a cputchar, I guess. Window. I don't remember this stuff. cputchar. So window character, foreground, background. Okay. So window character. Let's say an X or something. We need to cast this into an int 8. And then we need coloring. Let's just do 0, 0 for now. And then we need to update the screen. So cupdate window. And I guess this should pretty much be it. Let's also, let's not make this so big. Let's just do 25 by 10. Alright, let's run this and see what happens. Not entirely what I would expect. And what happens if we try to print several characters? If we just do a couple of these, what happens then? Not much. Perhaps we need to initialize this thing. Let's see. I saw something about let's see, where is it? This perhaps. So this basically sets the screen mode or whatever. 40 times 25 monochrome. Let's try this one. So 40, 25. 40, 25. Like so. And so let's create some kind of protected int 8 ANSI mode. And let's not take any argument right now. And this is going to return static string, which looks something like this. The escape character is x1b. So we'll have one more of these and see mode like so. And maybe we shouldn't return it actually. There's not really a point. So let's make this a void instead. And we do the same here. Void. And instead of returning this thing, we can just do write to the standard out and we take this static string need to change this to x1b, and this is one character. So 1, 2, 3, 4, 5. Something like this. So before we start all of this, we will just do ANSI mode like this. Let's see if that makes a difference. Did not. I guess we need to clear the screen. We can do that when we set the mode actually. So let's see, there must be some clear the screen. Let's use to clear the screen, escape X X1 B and a C. It's not in the official list, but let's try it. So first we do this, and then we write this string, which is 2 characters. Let's see if that makes a difference. No. must be something similar to this. Move cursor, move cursor, move cursor. Erase. Erase in display. Erase from cursor until end of screen. First beginning. Erase entire screen. Here we have it. Here we have it. So first this escape code, followed by this thing. So this is 1, this is 2, 3, 4. Okay, it clears the screen. By the way, I think we missed one thing. When we update the screen, let's see. We run updatewin. And we print the character and the color codes, but we haven't moved yet, right? We haven't moved, so we need to do that first. So let's say we have an ANSI move, and we provide the window X and the window Y. We do have an ANSI move. But we didn't call it XY. Alright, let's see what happens. Okay. At least something happened, right? But we don't actually want to move to the X and Y position, because here we are going through each and every one of them. We need to jump to the index, basically. Maybe we can change the X and the Y in the loop, in this loop right here, before we call the update win. I think that's the easiest way. So we need to be able to calculate it from the index. So we need an int X and a Y. So the X, let's start with a Y. So the y should probably be the index divided by the window rows. Minus 1, I think. And then the x should be the modulus of the same thing. So idx, maybe we need this. IDX mod window rows minus 1. Yeah, I think that's it. And then we just set window y to y, window x to x. And we update the window, which makes use of these when we do an ANSI move. And then we can go to the cputchar, or the cjump, and make sure that we don't call this ANSI move here. No, we don't. ANSI move. It's called here and only here. Okay. Exciting. Let's see if this works. Or at least if we get some other results. Maybe we should try something smaller to begin with. So let's see. So set the ANSI mode. Do a jump. And let's comment all of this out for now. And instead of just doing this ANSI mode, let's still do the ANSI mode, but let's do an ANSI move. X and Y. So let's say 5 and 10. And here let's just print an X. And see if we can do that at least at the correct place. Okay, that seems to work actually. That's a good sign. Can we change its color? So let's see, ANSI color, ANSI reset. Give ANSI color, and let's just pick something, 5 and 6. so. Okay, that works too. That's promising, at least. So we just need to figure out what's wrong with our structures. Because it probably has something to do with like the bitmap or something. So we need to create show functions for our data structures, like the window, the state, framebuffer. And then we can probably see what's wrong. Because when we do this cputchar, what happens? Let's change the x and the y. And we use our sfbxy. And in the end we will update the frame buffer based on this. Yeah, so if we create show functions for the bitmap and the frame buffer and, well, the window and state too, then we will probably see what's wrong. Alright, welcome back you guys. So, we are not going to be able to solve this problem without creating a show function, so we know a little bit about how the data structure looks like. So we need to create 3 different functions for the 3 different data structures. So let's create one for, let's start with the frame buffer, then the window, and then the state. And I'm going to make this pretty simple. I'm just going to make a void function. So show frame buffer, and the only argument it's going to take is the frame buffer pointer, like this. And same with the other 2. So we'll have a show window, and a show state. So let's start writing the first one, and then we can hopefully copy a lot from that to the other ones. And to make it a little bit easier, I am going to copy the contents of this data structure, and let's paste it in here, make a comment out of it. Like so. And let's write our function. So we'll have a void, I guess a protected void, show frame buffer, and we're going to have a frame buffer FB. so. Alright, so first of all we need to print this contents of the frames, but we do need to know how big this thing is, right? So shall we take the window as an argument, or should we have the size? I think we are gonna take the size route actually. So we'll have a frame buffer and we're gonna have an int16 like so. And this is going to be, what should we call this? Num for number of frames, right? Alright, so let's start by printing out the different frames, and in order to do that we need to divide it up in the different parts, I guess. Yeah, I think so. So let's say we have a int8 color. We have an int8 foreground and a background, and we have an int8c for the character. So this we have done before. Let's also have a frame for the frame itself, and we need to have an index as well. So we'll have a for loop where we set the index equal to 0. We're gonna loop it as long as idx is less than num, and we'll just do idx++. So we read in the frame, which is going to be the fb frames at index. And let's check if the whole thing is 0. Then we can just print, let's say, 2 zeros. Otherwise, we need to do something more clever. So first we will isolate the character, and we do that as we have done before by taking the frame and we AND it with, let's see, ff00, and then we shift it right 8 bits. And to get the color, we will just take the frame and AND it with 0x00ff. To get the background, we take the color, AND it with 0x00 f0, and we shift this 4 bits. And if you don't understand anything of what I'm doing right now, please check the last episode or the beginning of this one, or perhaps check out my video on binary operations, where I go through this in great detail. So we'll take the color, and in this case we'll just AND it with 000f. And then we have the different parts. So how do we print that in a good enough kind of way? I guess we don't need to be all that clever. We can start with a character. And shall we print that as an ASCII character or the number? I guess we can do an if statement if the character is 0. In that case, we can just print 1, 0. And then a slash. Otherwise, we're going to print 1, 0. No, not 1, 0. One character and a slash, and that character is going to be the character, and we need to cast this to a char. And then we're going to print the colors. So let's just do 2 regular integers like this, where the first is, let's start with background, and then we take the foreground, like so. And at the end here, we print a space. And if, let's see, if our index number is divisible by 8, let's say, in that case we're going to print a new line. Something like this. And then we're going to print a new line at the end as well. Return. We're going to add some more things, but let's start there. Alright, so that is done, but this was only the first field of this data structure. The next is the first 1 byte. That's pretty easy to do. Can even do it here. So first 1 byte, and this is going to be a hexadecimal 16-bit number. So let's do %.04 HX for 16-bit, and this is the framebuffer first 1 byte, or first 1 bit rather. And then we have the bitmap. So we'll just do a loop with the indices as we did before, similar anyway. So we'll set idx to 0, we'll loop as long as it's less than num, and idx++, and at each iteration so let's see here. Well, we need to define the bit, so bool bit and the bit is going to be equal to the get bit from the framebuffer bitmap at the index. Maybe we can do something like bitmap. Let's do a new line here, jump out 2 steps. Let's do frames, new line, 2 spaces, and at the end here, when we do the new line, we do space again. Okay, so now we have the bit, and I guess we'll just print it out 8 by 8. So we are going to have an integer, and if the bit is true, we want a 1, otherwise a 0. And if the index is divisible by 8, in that case we wanna print a space. And if it's divisible by, let's see, 64, so 8 times 8. In that case, we are going to do a new line and 2 spaces. So let's make this an else if, because both can be true. And then we'll just print it out just like that. And at the end, let's say we print 2 new lines like this. Okay, and let's try this out. So if we go down to our main function, and right before the C update, I think we can do this thing. First we need to calculate the number. So num is going to be equal to the window calls -1 times window rows -1. That's our num. And now we can just call show frames. No, show framebuffer. And we need to provide the window framebuffer and the num. And we should do this before the cupdate. Actually, let's don't do the cupdate. Alright, let's try this. Six. That's right. Missing semicolon. And 39. Here we need to have the question mark. Now let's try it out. Alright you guys, now I finally figured it out. I have been troubleshooting this for days, literally. Look at this bitmap. So the least significant bit in this byte is set, and same here, and same here, and same here. But if we scroll up and look at this, here I have a whole bunch of characters in a row. And if we look at the code, I have all of these, right? So the bitmap is not calculated correctly, and I finally figured out why. I made it like this. I defined the bitmap as a bool, which means that since I am treating each unit as a byte, performing bitwise operation of those bytes, when I go to the index bit divided by 8 of the bitmap, I actually skip 7 booleans each time. So the only thing that is needing to be changed is changing this into an int 8 instead. If I do that, recompile and rerun it, now I have all these ones in a row, which means that if I go back to the code, put back the cupdate and remove this show thing, we can remove this as well. Now it should work, right? And it does. So now we can print stuff to the screen in different colors wherever we want to. Before we end today, I want to create one more function. I want to have something similar to mkset, which fills a memory segment with a specific byte. But I want to have something like, by the way, all of these should be protected, right? I want to have something like a framesset, which fills the entire frame buffer with a specific byte and in a specific color. So it's going to be something like so what this is going to be Do we want it as part of the public API? Yeah, let's do that. Okay, so let's call it cframeset. And it's going to take a window and character, color, like so. Yeah. So how do we make this function? It should be pretty simple, I guess. It's going to be public void cframeset with a window win with an int8 c and int8 foreground, int8 background. If we don't have a window, let's just return. Okay, so how do we do this in a good enough kind of way? We could loop through and call which is, am I thinking, sfbblinear. Maybe we should. It would be a whole lot of quite unnecessary function calls, but I think it would be rather fast anyway. So we can always optimize stuff later. So let's see, we're gonna have a frame. No, we don't need a frame, but we need an index. And we need to have a max value, right? So the max, as usual, is the window calls -1. And maybe we need to update this formula as well, because maybe it shouldn't be -1 in all cases. So we'll see how this looks. So this is the max, so we can do a for loop. The index is 0, less than max, index plus, and then we'll just call set framebuffer linear. And what is the signature? Window, character, foreground, background, index, okay. So, window, character, foreground, background, index. And then we return. So, let's see how we're gonna use this thing. Let's clean these out a little bit. We can save one. But comment it out. We don't need to jump anywhere right now. So let's just call cframeset with the window, and the character is just going to be a space here. And what colors do we want? Let's go back to this nice web page we have had. ANSI colors. No, not colors. ANSI codes. And you can find this link in the description. So let's see, where do we have colors? We could have something like let's say a blue background and a black text. So we're gonna have no background first. I mean foreground first. So 0, 4. 0, 4. And this should, if the calculations are correct, this should fill the entire screen, right? And do we have the update? Yes, we do. I guess this is correct. But I think we have the wrong proportions. Let's go to the init function and maybe switch these up. So 25 and then 40. Okay, that looks pretty good. Maybe we should increase the size. So let's say 80 here instead. Pretty cool. And let's print something in the middle of all that. Not exactly in the middle, because I don't want to make all these calculations, but so let's do a framesets, and then we'll do a cputchar, and we'll use a window, and let's say int 8 something. And we still want to use 0 and 4. And let's do a C jump. Give the window, and let's see, 80, 25, let's say 10 and 30. And let's see if this works. Would you look at that? Hello! So, now we can finally put stuff on the screen. Ladies and gentlemen, we are starting to get there. Now we only need to create some string functions so we can deal with this more easily. And we also want to create something like taking inputs from the user, like moving stuff around with the arrow keys or whatever. So I hope you liked this episode. Please like and subscribe and hype the new feature. If you don't know about it, you can not only like and subscribe, but you can hype. And you do that basically at the same step. I wrote a message on a text message on YouTube describing how it does. Look at the comments to that post. And please hype this episode if you think I'm worth it. And that will extend the spread of my channel. So thanks for watching. Thanks for today.